Okay, so we have talked about the measures of center. So we're looking at these curves. We've talked about locating the center of that curve. And we've talked about the mean, median, and mode. And in a good set of data, the mean, the median, and the mode will all be the same value, right in the center. By a good set, I mean a normally distributed set of data, a perfect bell curve. We talked about skewed. So we have data like this that is skewed to the left. Data like this that is skewed to the right. Well, the mode, now let me draw the bottom line in here. The mode is always going to be at the highest point of the curve. So that's going to be the mode. Because that's the one that's the most often. The highest point of the curve is the value that occurs the most often. The median is going to be pulled slightly away from that peak by the skewed data. So in the direction of the skew is going to be the median. Depending on how severe that skew is and how many extreme values we have, the mean is then going to be stretched out the furthest away from the peak. So like we said, if you have a really large set of data, the mode is a decent measure of center, but only if it's really a large set. Normally that median is the best measure of center. So next we want to talk about measures of spread, sometimes referred to as dispersion. In other words, how scattered out are the data points? Again, I'm going to give us a basic set of numbers, and I am going to put this set of numbers in order from smallest to largest just to make it easy on myself. So let's do 7, 12, 14, 19. Oh, let's see, what have I got there? We'll go 23. So we've got just 5 numbers there. Our first measure of spread is something called the range. Now earlier we had the mid-range. That's related to the range. The range is just the largest number, which is called the maximum, minus the smallest number, which is called the minimum. So what's the largest number in this data set? 23. What's the smallest number? 7. So that gives us a range of 23 minus 7, or 16. Now the problem is, I can create another set of data that looks like this. This set of data is less spread out than the first set, but it has exactly the same range. The range is still going to be a maximum of 23 minus a minimum of 7. But if I were to do this out with a dot plot, we're at 5, 10, 15, 20, 25. This top set here, I'm going to do in black. We've got a 7, a 12, a 14, a 19, and a 23. The bottom set, which I'm going to do in gray, I have a 7, a 14, a 14, and a 17, and a 23. You can see that gray set is more concentrated towards the center. It's less spread out. So the range does not distinguish between these two sets of data. So the range is not a great measure of spread or dispersion. It's a quick measure. And if it's a normally distributed set of data, it's not a bad way of figuring it out. Our second one, the one that we use more often, is called, we're going to combine the variance and the standard deviation into one here. The variance and standard deviation are actually slightly different. And it depends on whether we're taking a sample, if we're calculating the standard deviation of a sample, or if we're calculating the standard deviation of a population. We, for this class, are always going to assume that we're calculating the variance or the standard deviation of a sample. We're not even going to talk about the standard deviation or variance of a population. It's just slightly different, but you never do it. Very seldom do you have all the data sets for every element of the population you're going to calculate a standard deviation for. So it's just not practical. So to calculate a standard deviation, there is a really ugly formula given in the book that I'm not even going to bother putting on the board because it doesn't make a lot of sense unless you've had a lot of algebra. So we're going to take the simpler approach, and we're just going to do this as a 6-step process. And we're going to do both the variance and the standard deviation at the same time. Yeah, simple 6 steps, right? The variance is actually the result at the end of step 5. Then we go one step further to get the standard deviation. So step 1 in our process is going to be to calculate the mean. So we're going to do the top set of numbers here. So we're going to find the mean for 7 plus 12 is 19, plus 14 is 33, plus 19 is 52, plus 23 is 75. And there's 5 numbers there, so we're going to divide by 5. So that's a mean of 15. Step 2. Subtract the mean from each number. What do I mean by that? Well, I have 7, 12, 14, 19, and 23. And I am going to subtract the mean of 15 from each of them. So 7 minus 15 is a negative 8. 12 minus 15 is negative 3. 14 minus 15 is negative 1. 19 minus 15 is 4. 23 minus 15 is a positive 8. Not that it matters, but this set of numbers right here is what is called the deviations. If I were to add up the deviations, the sum of those deviations should add up to 0. If I total them up, that should be 0. Now that's really meaningless, but it's a way to double check. If you want to check yourself partway through your calculation to make sure you didn't screw up, you add up that column and make sure it's 0. If it's not 0, you mess something up. The biggest mistake that usually gets made at this point is maybe you calculated your mean wrong. So if your mean is wrong, then this will be wrong. Step 3. Is to square each deviation. In other words, square each of those numbers. So negative 8 squared is a positive 64. Now I know I've given you this warning before, but I'm going to give it to you again. If I punch it into my calculator like this, negative 8 squared, it's going to try to tell me it's negative 64. That is not true. Any number squared is positive. So when I enter it in the calculator, for many of your calculators, you must put it in parentheses like that, negative 8, and then squared to be positive 64. The key is to remember anything squared is positive. So all the numbers that are going to be in this column here better be positive. Negative 3 squared is positive 9. On your calculator, squared is over on the left by the number. Okay. So negative 1 squared is 1. 4 squared, 4 times 4 is 16. And 8 squared is 64. Step 4 is to find the sum, in other words, the total. So I add those all up. I have 64, 73, 74, 90, 154 is my total. Bless you. Step 5 is the tricky one. Step 5 is to divide by n minus 1. Now remember, for this data set, we said n equals how much? How many numbers are in this list? 5. So n equals 5. So therefore, n minus 1 is 5 minus 1. That equals 4. So we are going to divide this by 4. Which I believe is 38.5. Is that correct?
Yes, 38.5.
Perfect. This number we just calculated here, we said at the end of step 5, we would have the variance. 38.5 is the variance of this data set. Only one more simple step and we're there. Step 6. Is to take the square root. The square root of 38.5. For most of your calculators, you do second and hit the x squared key to get the square root. 38.5 is 6.205. We will round that to 6.21. That is our standard deviation. A little comment on rounding. Calculating a measure of center. So the mean or the median, or the mode, you shouldn't ever have to round, or the mid-range. You go 1 decimal place past the data. So for these data sets I've been giving you, they're to the nearest 1. So you'd round the measures of center to the nearest 10th if they had to be rounded. For spread or dispersion, unless you're told otherwise, you round it 2 decimal places past the data.
Can you explain again, what do you mean by data?
Well, here the data values are these values right here. They're to the nearest 1.
Okay.
So this is the ones place. There's no decimals. So that's why I rounded this to 6.21, because that's 2 decimal places past what the data is expressed in. Our data values have no decimal places, so our spread will have 2 decimal places at most. No. No, that's just because what the data values themselves actually were. Now, in my math lab, they do a really good job on each problem of telling you what to round to. So these, like I said, these are unless otherwise stated. If you are told to round to a different value, then round to that value. But if it doesn't tell you, then you round the centers to 1 decimal place past the data and the spread to 2 decimal places more. So I want to take this second set of data we had here, this one, and I want to see if we can find standard deviation of this set of data. More specifically, since this is a long process and this is our first really tough calculation of the night, I want to see if you can find the standard deviation of that set of data. So I'm going to give you 4 or 5 minutes here to find the standard deviation. Now I'm going to help you out with the first step. Step 1 is to find what? The mean. So 7 plus 14 is 21, plus another 14 is 35, plus 17 is 52, plus 23 is 75. There are 5 numbers there, so we're dividing by 5. So once again, our mean is 15, just like it was with the last set. I want you guys to take it from there. Let's see how you're doing. I know some of you may not quite be done yet. So we found the mean. The second step is to subtract the mean from each. So 7 minus 15 is negative 8. 14 minus 15 is negative 1. 14 minus 15 is still negative 1. 17 minus 15 is 2. And 23 minus 15 is 8. Now those are the deviations, and again we could add those up and make sure they're 0, which they are. What is step 3? Not quite yet. Square them. Yep. So negative 8 squared is 64. Negative 1 squared is 1. Negative 1 squared is still 1. 2 squared is 4. 8 squared is 64. Now step 4 is add them up. There you go. Total. One of those nights, I know. So we get 134 if we add those up. Step 5. Divide by n minus 1. Always n minus 1 if it's a sample. If it were a population, it would just be n that you would divide by. That's why we said we're assuming it's always a sample. So this is 5 minus 1 is 4. So we're going to divide by 4. Which is going to give us, what, 33.5?
Yep.
That'd be the variance. And what do we still have to do to get the standard deviation?
Square root that.
Yep, step 6 is the square root of 33.5. Which gives us 5.79. That's our standard deviation. On your calculator there, you first will hit the second key in the upper left. Then you'll hit that x squared key. And then you'll type in 33.5. So 5.78, 79.
What's the key right here above it?
See, it says x. Oh, that's the caret key. That's for other powers other than squared.
That's what I put in there.
No. Good news. That's all your new material for the night. I think you guys have taken enough abuse. There is no quiz. But there is a new homework. It is due for next Wednesday.
Already done. And the assignment after that.
Perfect. So again, here at Rice Lake, the computer lab next door is open. There are facilities at each of their campuses if you want to use them. Otherwise, we will see you next week.